Welcome! I got a new course, and it's called Learn Python by Building a Blockchain. I guess the title speaks for itself. It's a Python course. You will learn Python from scratch, no prerequisites required. You will learn all the core syntax, features like list comprehensions, using more complex data structures like tuples or dictionaries. You will learn object-oriented programming with Python by using classes and inheritance. You will learn how to spin up a web server and handle incoming requests with Flask. You will learn how to send requests, how to work with files, and so much more. So really, a thorough Python course that introduces you to the language. And it does so by building a real cool course project, a basic blockchain and your own cryptocurrency. Now that sounds very fancy. Well, why did I choose that course project? Well, I chose to build a blockchain because it turns out that we actually can gradually enhance that blockchain, start very basic, and then add more and more core features of the blockchain technology as we learn more about Python. So it's a really cool project that allows you to apply your newly gained knowledge and build something realistic. That's always important to me. I want to build course projects that are connected to something you know from real life, that aren't too abstract. Now, the blockchain, on the other hand, is kind of abstract. You hear about that technology a lot, and I'd argue that most people don't really know how it works. And that's another cool thing about the course. Whilst it is not a blockchain course, it's not about the blockchain only, it's about Python. But whilst that is the case, you will learn a lot about the blockchain there. You will learn about the core concepts behind it, and therefore you hopefully understand that technology a bit better too. So it really has these two parts, Python and the blockchain, two very popular topics now connected in one course, which hopefully allows you to learn a lot about Python and also learn a bit about the blockchain whilst you're going through it. I'd be more than happy to welcome you in the course. If you are interested, you'll find a link with a nice discount in the video description. And I also attached a couple of lectures at the end of this video to allow you to see if that course is for you. As I said, I'd be more than happy to welcome you there. Otherwise, see you in all the other videos on this channel. Bye. So what is Python? Python is a programming language which you can use for many different things. It's an extremely powerful, easy to use, and object-oriented programming language. Now, what does this mean? It's powerful because it offers good performance. It runs on all major operating systems, so it doesn't matter if you're using Mac, Windows, or Linux, it'll work on all of these, and you can use all of these for this course. And it's extremely versatile. To be precise, if we have a look at its versatility, we can see that we can use it to build simple scripts or programs running on our desktop with or without a UI, that you can use it for web development to run server-side code, so code that does something on the server, sends back HTML documents to your users and stuff like that. And another very popular way of using Python is for data science. And after this course, you will be able to dive into all of these different areas, because in this course you will learn all the core basics about Python on which all these pillars basically build up. Now, what do these pillars mean in detail though? Well, we can build scripts and programs. For example, build a simple calculator, which we execute from our system built-in command line. We can write simple utility scripts like cleanup scripts or scripts that save some data to files. Of course, we can also build complex programs. We can add a UI to build real desktop applications. This is also something which is relatively easy to do thanks to Python's rich ecosystem. Another cool pro argument, it has a broad ecosystem of third-party packages and libraries you can add to easily add new functionalities to your programs. When we have a look at web development, we take advantage of that. There are a lot of packages that make it easy for us to write server-side code. And we're then able to use Python as a server-side language. We're able to build full-stack apps where Python takes in requests and sends back HTML responses, or API applications where we also take requests and send responses, but where we interact by just sending data and no HTML code that could be rendered by a browser. This allows us to build web applications to which other programs could communicate, and this is actually also what we'll dive into in this course, but more on that later. We can also use frameworks like Django or Flask. These are these third-party libraries I mentioned to make our developers' life a lot easier. Now, when we have a look at data science, another very popular way of using Python, there we also have a rich set of third-party programs that make statistical calculations and working with numbers very, very easy. We also have easy ways of gathering, importing, cleaning, and using data. And we can do all kinds of statistical analysis, implement machine learning models, and use them in our apps. So Python is extremely versatile, and therefore learning it definitely is a great idea. And all these areas build up on the basics you learn in this course. But Python is not just powerful and versatile, it's also easy to use. It has a clean and simple syntax, no extra fluff added to it. It has a batteries included approach, which means that just after installing Python, you already got a lot of possibilities of using it. You don't need to import and implement third-party packages, which you have to download and install separately for many things. You can just use what's built in. That's really great. And it offers a great documentation. So if there is something you're stuck with, or you're not sure, you dive into the docs and you get many examples there, many ways of learning Python in case you can't find other resources which also help you. Because as I said, there is a rich ecosystem offering many resources too. So that's pretty amazing. And now lastly, it's object-oriented. That is something which will become clearer once we dive into what this means in a separate module in this course. If you already got some programming background, you'll be happy to hear that Python uses classes, inheritance, that it supports all these features, doesn't force you to use them, but offers the possibility, and using these features offers many advantages, and that makes the language even more powerful and easy to use in the end. It's no wonder that Python is very popular, therefore. If we have a look at this graph, we see Python is extremely popular and is gaining popularity, surpassing many other languages here. And it is, of course, doing that because it's easy to learn, it's very versatile, and it has this cool ecosystem with many third-party packages, and therefore it's highly extensible. So learning Python was always a good idea. Now it's a better idea than ever before. So with that, let's just install Python and write our first simple program with it. Let's get started using Python. To use it, we have to install it first. And that is also true if you are on a Mac or Linux. There it typically is pre-installed, but also typically in an older version. So make sure to install the latest one, that's really important. And you do install it by visiting python.org. And as I said earlier, you can use Python on Mac, Linux, and Windows. And you always install it from that page. On that page, choose Downloads, and then Python 3. Whatever the latest version is when you're viewing this. In my case, it's 3.6.5. Now, it's automatically giving me the Mac OS X download here. If you're on Windows, you visit that same page, and you simply choose the Windows download there. It should automatically offer that. On both operating systems, simply click, and the download should start. Once the download finished, simply click the downloaded file, and the installer should open up. Now on Mac, simply click Continue, 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 agree to the license agreement, choose the place where you want to install it, click Continue one more time, and finally install it. Now on Windows, the steps are basically the same, though there are two important things. Make sure to select this checkbox where you add Python to your path variable. This is important so that you can later execute it from within your command prompt. And then if you choose the manual install option, also make sure you install Python, this pip thing here, and all the things you see checked here, and also make sure that here the environment variable part is checked. This is important so that you can conveniently execute Python from within your command prompt later. With all that said, on both operating systems, you can simply hit install and wait for the installer to finish. Once it did finish, open the terminal on Mac and Linux, or simply your normal system command prompt on Windows. Now, these are the tools we'll start with in the course, but no worries, later in the course we will also use a real editor and work with real files where we write our code, and far later into the course we'll also attach a more beautiful UI. So this is really just what we're starting with. Now, I'm using a Mac here, that is why you're seeing a terminal, but the steps are the exact same if you're using Windows in the command prompt. After installing Python, simply enter Python here as a command directly in the terminal or command prompt. After you do this, you should enter this input mode here. You see 3 greater than signs on the left, and this now means you're now in the Python console, so to say. This is called the REPL, and I will come back to what REPL means in the next module. The cool thing is, here you can now type Python commands and directly execute them. Later we will also store them in files so that we can execute a whole file in one go. But here we can start simple, and you can, for example, simply enter 2 plus 2 and get back 4. Obviously, it's more than just a simple calculator though. So let's build our first simple program in the next lecture. So let's start building something more exciting than just a simple calculator with this REPL thing. And the steps I show here are shown on Mac, but they are exactly the same on Windows. So what I want to do here is I want to get some input from the user, store that in a file, and then also open that file and read what we stored there and output it here in this command prompt. Now, to get input from the user, we can use a function Python ships with, the input function. And you will learn more about all the functions it ships with and what exactly is happening here throughout the course, of course. Input is a function. You execute it by typing input and then 2 parentheses. Between the parentheses, you pass a so-called argument. That is something that function will use. And the input function is defined by Python. It's built in to show you the text you're entering here. Make sure to use 2 quotation marks and then wait for the user to enter something. So here we could say, please enter your name, colon, and then a blank. And if I hit enter, you see it's outputting that text and waiting for me to input something. You can tell that it's waiting by the fact that there are no 3 greater than signs on the left. So I can type max here, and if I hit enter, it's outputting it below. That was the input it received. Now that's nice, but I want to store that in a file, right? Here we can use another concept, variables, something I'll also come back to in this course. And we can simply add a variable by typing any name you want, like name, but you could also type my underscore name, anything like that, and then an equal sign, and then input, please enter your name. What we're doing with that is we're getting the input and then we're storing it in that variable so that we can use it later. If I now hit enter, I can again enter max, and now you don't see max as an output. Instead, now if I type my name here, so the name of that variable, now we see the output. This allows us to now use that value as often as we want. And now if we want to store it in a file, we can call another function Python ships with, the open function, which will open a file for us. Now, I'll store the result of that function in another variable named file. So file equals is whatever open returns to us. And now open needs 2 things. It needs to know which file to open and how to open it. Do you want to read? Do you want to write? So I will open a file which I'll name name.txt, and I'll set mode equal to W for write. And if that syntax is a bit unclear, well, just make sure to type it correctly here. You will learn what all these things are, 2 different arguments for 1 function throughout the course, no worries. But with that, we're basically telling Python to open that file and give us write access to it and store that address or that pointer to that file in that file variable. If I now hit enter, we can type file here, and this is this strange output, which essentially tells us that it somehow worked. And now we can say file dot write my name, and this tells Python to write the content of my name into that file. If we now hit enter, you can ignore that output. We can now close that file by calling file.close with parentheses. And if you do that, let's quickly navigate into that folder where you're executing your terminal or command prompt in the Finder or Windows Explorer. You can tell which path this is running in on Windows on the left side of your terminal when you enter Python. There you should find the path it's currently running in. On Mac, it should simply be in your user's main folder. There you should find a name.txt, and if you open it, you should see the name you entered in there. Now, of course, we can do something cooler than just store the value there. We can also read it back into Python. We can use our file again and call open again, name.txt. Make sure to don't forget the quotation marks here. And now set the mode to R for read. If you now hit enter, you're opening that same file, but in read mode. And now you can call file read. And if you hit enter, it gives you the output of the file here. And that was a lot of new stuff, a lot of things where you might wonder what's happening here. And we'll learn all these things, no worries. But I hope this gave you a first impression of what you can do with Python and how you can give your computer instructions to execute, which in turn allow you to write more complex programs, as you can use these instructions and way more other instructions and commands in any combination you want to build any kind of program you want. And we'll do this in this course. We'll build a blockchain. So what is a blockchain then? You probably heard about blockchains, or at least about Bitcoin and cryptocurrencies in general. Bitcoin is a cryptocurrency, and cryptocurrencies are based on the blockchain technology. The blockchain technology can sound very abstract, but in the end, a blockchain is just a distributed data storage, so the same copy of the data is kept on multiple machines, which are connected, and each data storage, so on a machine, the blockchain, is just a chain, a list of data stores, containers, the so-called blocks, which in turn are connected to each other. So the order of the blocks matters. And every block is really just like a folder on your system, which contains some data. It's not technically a folder, but you can think of it as one. So we got all these folders where each folder knows about the folder before it. This builds up a chain, so the order does matter. And then the whole folder holding all these subfolders, this is your blockchain. And what's inside a subfolder, that's the data stored in the blockchain. And the blockchain is not limited to transactions. As you learned, the blockchain is a data store, and a single block in the end can hold any data you want. This could be some text, this could be a number, this could be a program you can execute. Or, as in the case of Bitcoin, it can be a list of transactions. More on that in a second. We, of course, don't just have one block, we have multiple blocks in a blockchain. And the interesting part is that they know about each other. To ensure that you can't manipulate data in blocks, because it's distributed across multiple machines, you want to make sure that the machines can check each other. Each block receives a hash or is hashed. A hash simply is some long text, you could say, that is generated automatically from all the parts that make up the block. So if you got a block with the data, hi, I'm in a block, and then let's say you have some metadata in that block, like a unique ID for every block, then you could take both, use some hashing algorithm, we'll use a plugin for that in this course, and then it spits out some text, and you'll always get the same text for the same inputs. And that hash, as it is called, is stored in the next block. So whenever you change the previous block, the next block will detect, hey, the hash I stored doesn't match the recalculated hash for that updated data. Because same input yields the same output. If you change the input, you change the output. And therefore, the next block, which stored the old hash for the old input, would recognize that something went wrong. That is an important security mechanism. And that is how the blockchain is built. You got all these blocks, and the next block always knows about the previous block. Now, that's a lot of theory. What's a cryptocurrency then? Because a cryptocurrency is the most prominent use case of a blockchain. And a cryptocurrency is really just something which uses the blockchain technology. If the data you store in a block is a list of transactions, and a transaction is basically just a piece of information where you say who is sending how much to whom, these three things are important. If you got a list of such transactions in a given block, you obviously can take advantage of the security mechanism that these transactions can't be edited without the next block recognizing it. And therefore, now you have a cryptocurrency. You have your own cryptocurrency managed in your blockchain, which is distributed across many machines and which is therefore secured. And that is what's used by Bitcoin, Ethereum, Ripple, and all the cryptocurrencies you know. So back to the picture from before, our data now simply is that list of transactions. It's that simple. And what are the coins then? Well, the coins is just something you come up with. You can give the things you're transferring in the transactions whichever name you want. Coins are transferred with transactions, that's all. You have to, from, and how much. The how much, that is your coins, and you can name them whatever you want. The coins normally can't be changed to other real currencies unless you find someone, of course, who says, hey, please send me some coins and I will give you this amount of US dollars or this amount of euros. This is how it works. The worth of the coins is really just what people think it is. And this is how it works for all these cryptocurrencies. That also explains their high volatility. It's a new market, and the true value of these things is still something we have to evaluate. And finally, coins are created with mining. Because of course we can send them around, but this doesn't create them. Mining is a crucial part, and mining is how new blocks are added. We will have open transactions where you want to send something to someone, and for that transaction to be confirmed, it needs to be included in a new block, which is added at the end of the blockchain. People who are adding this are doing the so-called mining because this process actually takes a bit longer. They have to solve a complex algorithm, and they get some new coins out of the system as a reward. So if we want to summarize it in a big picture, this is how a blockchain looks like. It actually runs on multiple machines, so-called nodes. You also might have heard of the term wallet. A wallet in the end is just a node. That is a simplification we'll use in that course. A wallet in the end is what enables you to send and receive coins. It's a piece of data which allows you to identify yourself, you can say. And then you can send coins through transactions to other wallets. And if such a new transaction is created, it's broadcast to the nodes. Nodes also distribute it across the whole node network. And they will verify a transaction while doing so to make sure you have enough funds and to make sure that you really are who you claim to be. And once a couple of transactions have been collected, one node will eventually bundle them up in a new block and then inform the other nodes about that new block so that it is added to the blockchains of all the nodes on all the different computers only after this new block and the whole chain it belongs to has been verified by all the nodes, of course. So that's the blockchain in a nutshell. As I said, I'll come back to all these core concepts throughout the course. In the end, it's a distributed, secure data storage where each block is a folder with some content, some data inside of it. And it's a cryptocurrency if that content is a transaction where we send coins from A to B. So now that we had a first look at what Python is and what the blockchain is, and that we installed Python and wrote our first program, let's see what the course as a whole has to offer for you. We're almost done getting started. In the next module, we'll dive into the core base syntax of Python. And regarding our blockchain, we'll start building a simple chain, a simple list of coins. For now, a coin will just be an amount, just a number, but it will be a great start. Thereafter, we'll dive into loops and conditionals, useful constructs that allow us to execute code either multiple times or only under certain conditions. Regarding our blockchain, we'll be able to then verify our blockchain and check if the previous block is still the block it was when we added its next block. So this connection between blocks, we can start verifying it here. Thereafter, we'll start working with more complex data structures because thus far we'll only have had a look at numbers, text, true and false, so-called booleans, and lists. Now we'll get into more complex data structures, which will then also allow us to work with real blocks and transactions, which is more than just a number. We'll dive deeper into built-in functions, so functions Python ships with, as well as text, so-called strings, and we'll be able to then calculate and output the balances of the different users of our blockchain. We'll thereafter have a look at the so-called standard library. This is this batteries included approach I was referring to. The many packages Python already has built in. We'll have a look at them and some selected ones in this module, and therefore we'll be able to start creating real hashes and the so-called proof of work, an important blockchain concept. We'll then learn more about reading and writing files, something we already did in our first Python app here at the beginning of this course. But here, of course, we'll dive into it a bit deeper and learn more about what's happening there and how we use it and how we can do different kinds of reads and writes. Regarding our blockchain, we'll finally be able to store and read our blockchain in files and not just in memory. We'll then also have a look at what we can do if things go wrong, how we can handle errors, how we can debug our code and find problems in our code. This will allow us to make our blockchain more robust and more secure, more safe. We'll then also have a look at object-oriented programming with classes. This is super important. It's a cool feature of modern programming languages, and Python has it too, even though Python is actually a bit older, but Python has that too. It allows us to write cleaner code, I'd argue, easier to understand code, and we'll use it on our blockchain to improve it and also to finally add a wallet, this identification data, which will in the end be super important for sending and receiving funds. Once we're done with that, it's time to dive deeper into modules and packages. We'll see how we can install third-party packages and split our code over multiple files. Regarding the blockchain, we'll be able to sign transactions, an important security mechanism. And then we're already nearing the end of this course, but we already learned a lot about the basics. But we won't finish the course before also diving a bit into HTTP and how we can handle incoming HTTP requests with Python and the Flask package. For our blockchain, this will mean that we can control our blockchain with a nice web UI and therefore leave that terminal-based UI we will have used until then. And thereafter, we'll also have a look at how we can not just receive requests with Python, but also how we can send them and therefore how we can communicate between different Python programs. We'll also use that on our blockchain to simulate multiple so-called nodes, so servers running on different machines, which now can communicate with each other to broadcast new transactions, blocks, and all that stuff. And thereafter, we're done. But of course, I'll also let you know what possible next steps are, where and how you can dive deeper, and what you have learned in this course. So a lot of cool content in there, covers all the basics you need to know about Python, and I can't wait to dive fully into it with you. Just a couple of other things about Python which you should know before we do get started. There are many good reasons for learning a language like Python. I already mentioned a lot. Its versatility, ease of use, and what you can do with it. I guess that's the versatility. You can build all kinds of things with it. But of course, there are other languages than Python too. There is C++, for example. This also is an extremely powerful language, and it also can be used to build all kinds of things, but it's a bit more complex than Python. You write things more from scratch than with Python. It has less things built in. You have to solve more problems on your own, I'd say. So it's a bit harder. And we mostly use it for desktop apps. It's very popular for creating games, for example. But there also often it just runs behind the scenes and you use some framework, some engine that builds up on it. So you can absolutely write C++ code, but it's a complex language and often you have other languages you use instead. And for example, Python, the version we're using, builds up on C, which is not exactly the same as C++, but generally related to it. And Python is an extra layer on top of that, you could say, which is more accessible. We also have languages like Java. Java is also a very versatile app, which we can use to build desktop apps, web apps, and even mobile apps with Android. And speaking of Android, we also have things like Swift or Objective-C, which you use to build iOS apps or macOS apps. We have languages like JavaScript, which run in the browser or also can be used on the server, so which you'd only use for building web apps. PHP would be another example, a language you really only use for building websites and web apps. And then you again have Python, which is very versatile, which you use for data science, desktop apps, utility scripts, and web apps. So which one should you choose? Why is Python the right choice? It obviously depends on what you're building. The cool thing about versatile languages like Python is that if you learn it, you're basically free to build whatever you want at any given time in the future. There are some languages, like JavaScript in the browser, where you have no alternative. Python can't be used to run in a browser to build the front end of a website, so to say. And Python also can't really be used to build mobile apps. But Python can be used for a lot of things that happen on a typical computer, or when we talk about web development, to build a web server. And therefore, this versatility really is a huge plus in case you're starting off and you're not 100% sure where you want to go, or if you know you want to go into a direction where Python is really strong, like server-side web development or data science. It's also important to recognize that only the two languages here on the right, Swift and JavaScript in this example here, have a UI attached to them. By definition, these allow you to build things where you see something with a nice UI relatively fast, because you're either building mobile apps or you're building websites, and both lead to things you can see, you can touch, you can use. Other languages like Python, C++, and Java are more on the build the logic part, less on the presentation part, and therefore you can add UIs to them, and we will in this course. But the core of Python and so on is really just the logic that runs on your machine, which is also the reason why for the majority of this course, we will work in the terminal and execute our code on our computer because it's doing a lot of logical work, which of course is the driver of any important application, the logic that happens in your program, not the presentation. But as I said, we'll add the presentation in this course too. Now, to come to an end in this module, let's have a brief look at the Python history and more importantly at the two important versions that exist. We got Python 2.7 and 3.x. Currently 3.6 is the latest version, soon it will be 3.7. Now what's the difference? 2.7 is an older version, it's the legacy of Python. Learning it right now is not really something I would recommend or anyone would recommend. There are some very, very, very niche cases, and if you need to cover them, learning the more modern version, 3.x, is still a better choice because it will then make it easy for you to learn 2.7 anyways. But generally, you don't need 2.7. 3.x is the future. So whichever version of 3 is currently the latest one, this will be the future of Python. Eventually, we'll probably also have a version 4, but for now we have version 3, and that will stick around for quite a long time. Version 4 is not even something that is known when it will be released right now. So that is version 2.7 versus version 3.x. 2.7 was released in 2010 and will be supported in 2020, so in case you need to use it, you got 2 years to go. But as I said, 3.x is the one which is currently still active under development. 2.7 is the last 2.x version. There will be no 2.8. 3.x is still under development, still gets new features and improvements. It is the future of Python. This is why you should learn it. 2.7 has a slightly different syntax. Mostly it's the same, but there are some differences because 3.x added a lot of improvements and additions to the language, made it better, brought some things in line which previously behaved a bit differently and strange, so it really added a lot to the language. There still are some, very few, libraries that only work with Python 2.7, but the vast majority of all third-party packages you might want to use have been ported to 3.x, so this should very rarely be an argument for picking 2.7. And therefore, learn 3.x. It's also the version we're using in this course for that reason. It's the future of Python, and of course we want to learn that future in this course. So we're pretty much done getting started. In the next module, we'll dive into the base syntax of Python. But I won't go there without letting you know how you get the most out of the course, because that is really important to me. You get the most out of the course by watching the videos. Now that seems obvious, but there's more than one way of watching videos. Make sure to watch them at your speed. If I'm going too fast, you can use the controls in the Udemy player to slow me down. If I'm going too slow, you can use them to speed me up. Also, pause regularly. If you're coding along, which I strongly recommend, you might need to pause a video so you can catch up with me. Because if I take too long breaks, everyone who's not coding along will have a hard time and will get bored. So I'm trying to find the right balance. And therefore it's important that you adjust the speed, that you take pauses, and also that you sometimes rewind a video if there's a concept which is not clear. It's an on-demand course, so take advantage of this. This is really how you get the most out of that. So code along, that is something I do encourage you to do. Do the exercises I offer in this course. They are great for checking whether you really understood a certain concept, the things taught in a certain module. And of course, use the course resources. So all the source code I show is attached to this course. And not just one code attachment per module, but most of the time I have multiple snapshots per module. You'll find them attached to the last lecture of each module and download and compare them to your code. If there is something which is unclear, if you're facing some strange issue, then my code is really there to help you. The same goes for links which you find in the last lectures of each module. There I provide useful links to other resources which allow you to dive deeper, learn more, or look things up. So definitely take advantage of this too. Now, sometimes you just get stuck though, or there is something you don't fully understand. Ask in Q&A. I'm happy to help there. I do read and reply there regularly, so I do my best to provide quick help in Q&A. But if you can help our students, that's even better. Not just because you're helping me, but because I really mean it like that. This is the way how you learn the most. I guarantee you that this is an awesome way of learning way more. Because asking is super simple, but answering, solving a problem, that's difficult. And I can only encourage you to do that. It can be challenging to go out there and put your opinion out there and solve a problem and potentially be wrong. But what could happen? You're wrong? So what? Then you get corrected and you learn again. So definitely give that a try and answer in the Q&A section. You'll find a lot of problems there and solving them. That is something where you can learn a lot and at the same time also help other students. This is how you will get the most out of the course. Follow these steps and you should have a more than solid knowledge of the Python fundamentals and core concepts and how to write Python programs by the end of the course. And a nice side effect, you'll also have a very solid understanding of what the blockchain actually is and how it works. So with that, let's finally dive into the next module and start with the base syntax of Python. So let's start diving deeper into Python. Now that we played around with it a bit in the command line and that we learned the basics about what a blockchain actually is, it's time to learn the base syntax of Python, its core features, and of course also to start building our basic blockchain. In this module, we'll therefore have a look at the REPL, so this command line again, and we'll also explore how we write a real Python program outside of this command line with normal files and an IDE, an integrated developer environment. Now that's of course just the setup part. Thereafter, we'll dive into the Python language and we'll start working with variables and see which data types we can store in these variables, and of course what variables are to begin with. Now we'll also see that with variables alone we can't do that much, so we'll also have a look at operators. We'll understand what operators are and which operators exist and how we can use them. Now, we will build a blockchain in this course, and as the name suggests, a blockchain includes the chain part, so multiple pieces of something. Therefore, in this module, we'll also explore what lists are and how we work with lists in Python. And to round up this module and write a program that is a little bit more useful than what we had thus far, we'll also dive into functions, a very useful language construct which we'll use quite a lot throughout the course. Now that's the Python part, you could say. What about the blockchain? Well, regarding the blockchain, at the end of the module, we'll be able to manage a list of blocks, and each block will actually contain some data or a list of data. So we will start working with our coins in this section, even though our blockchain won't be finished by the end of it, of course. We'll be able to add or mine data to our blockchain, and we'll also be able to output our blockchain so that we can see it. So with that, let's get started and let's dive right into it. Before we start setting up a local environment, let's go back to that command line approach. I called it the REPL. Now, REPL stands for read, eval, print, loop. The read part is basically the part where we enter something into the command line, like 2 plus 2. Evaluate or eval is the next phase where Python analyzes our command once we hit enter. Now, once it's done analyzing, it prints the result, 4 in this case. And the L part, the loop, is basically where it, goes back to start and waits for the next input. That is why we refer to that command line interface to the REPL. It is an interactive shell where we can just issue commands and let Python do the job. It's not really helpful for writing big Python programs, but it's a nice interactive way of working with Python and great for simple calculations and practicing. So let's go back to the REPL before we actually set up a real project with an IDE. Of course, we'll go back to the REPL to start working on our blockchain. And for that, let's leave out the node and transaction part and let's focus on the chain of blocks which contain data. Now that of course means we have two essential parts. We got the data and we got the chain. Now for the data in this module, we'll have a look at which types of data we can use in Python. Because no matter which Python program you're going to write, if it's a flight booking system, if it's your own search engine, or if it's a blockchain, you will work with data all the time. Data your user enters, data you read from some file, anything like that. And for data, we can basically work with numbers, strings, which is text, or booleans. And we'll have a closer look at what this is and what all these data types are in just a second. We also have more complex data structures at which we'll have a look at later in this course. Now, the chain in the end is just a list, a special type of data in Python as you will learn. Now, let's go back to the basic data types, number, string, and boolean. Numbers are divided up in integers, which is basically a number without a decimal place, and floats, which is a number with a decimal place. And we have both negative and positive values for numbers. We obviously work with numbers a lot in most programs. Be that your accounting software you're creating where users might enter their data, which typically would be numbers, or be that your blockchain where users send money around. Most programs work with some kind of numbers. We also got booleans though, and booleans are two kinds of values, true and false. Now, this might not look super useful if you're brand new to programming, but actually being able to tell if something is true or false is very useful if you're working with conditions, something we'll also dive in the course. Sometimes you want to check if something is true, if a certain condition is met, and then execute a certain part of your code, and execute a different part of your code if something is false. And therefore, booleans are a great way of handling that. But of course, again, we'll see how we use them in practice throughout this course. And strings are just text. Well, just like numbers, working with text is obviously something you do in pretty much any program. Again, be that your accounting software, where you enter the name of a certain transaction which is going on, or be that your blockchain, where you enter the sender and receiver of a transaction, which might have a unique name or something like that. Now, strings in Python can be written with single or double quotation marks. And you should simply pick either of the two approaches, whichever you prefer, and then stick to it. They are exactly the same. Now, finally, I already mentioned it, we got complex data types like dictionaries and objects. We'll not worry about them right now. We'll come back to that later in the course. Now, with that, let's see what exactly numbers are and how we can use them in a typical Python program. Now to work with numbers, I'm back in the REPL, or right now, to be precise, only in the terminal or command prompt of my machine. We enter the Python REPL by typing Python, assuming that Python was installed, which we did in the first course module. Now once you hit enter, you're in the Python REPL, and you can always quit it by hitting Ctrl-Z. Now let's get back into it though. A number is simply something like this, 2. If I hit enter, it just basically prints out what I entered. Now often you work with data, so not just with numbers, but also with strings and booleans, by storing them in so-called variables. Variables are data containers, you could say, which you define. So you could create a variable by simply typing a name for it, which could be age. The name is totally up to you. And then the variable only becomes useful if you store a value in it. So you can think of a variable as an address, like the number of your house. You then store something in there by adding an equal sign, and on the right side of the equal sign, you write what you want to store in that address, so in that variable. For example, 29, which would be my age. If you hit enter here in the REPL, it will not output anything, but if you now just type age, it will print out the value you stored in age. Now this already is a very useful and important part you gotta understand. We will work with variables a lot in this course. Any program uses a lot of variables because, as the name suggests, they allow you to do dynamic calculations. You can not just hard-code a value in there, you can also manipulate that value whilst your program runs. For example here, if I type age again, it again prints 29 because that's the value which we stored, and it keeps that in memory. It does not clear it after we output it one time. And if we now, for example, set age equal to 30, and I type age again, it changed it. It overrode this. We could also write age equals age minus 1. So now we would take the previous value which we stored in age, deduct 1 from it, and store that new value, which is calculated on the right side of the equal sign, back into the age variable. If I hit enter and type age again, it now outputs 29 for that reason. And this is the usefulness of variables. We can do a lot with them. We can run all types of calculation, store in between results, which we might need at a later point of time in our program, and of course, also output them to the users. And thus far, in this case here, we only worked with numbers, with integers to be precise, with numbers that don't have a decimal place. Of course, you can also store floats in a variable, like here. Now it's 29.5, and if I output this, we see 29.5. And obviously, you're not limited to numbers. You can also create a variable which is named isOld. The naming convention here, by the way, in Python is to name it like this. If you got one variable that consists of multiple words, you cannot write isOld with a blank. That's invalid. It has to be one word. But to still make it easier to read, you use underscores to separate words. So you got all lowercase names with underscores between the different words. This ensures readability and is valid Python syntax. But back to what I originally wanted to say, you can store, for example, true in here. That's a boolean. Do you remember that slide? True and false. Now you got isOld in here. And with that, you can of course also output that. And later, once we learn about conditional checks, you can use that to check if isOld is true, because let's say that is calculated dynamically, and then run a different code if that is the case, instead of running the normal code, which you might run if isOld is false. Now, last but not least, let's also have a look at strings. If I enter name, the important part here is the quotation marks. So single or double quotation marks, both works, and then the text, in this case, max. Make sure to also close the quotation marks. Now, if you output this, you got the name printed here. So these are the three core values or data types with which we work in Python. Numbers, where we have integers and floats, booleans, where we have true and false, and strings, which are just text, enclosed by double or single quotation marks. Now that we had a first look at the important data types and how we use them with the very important concept of variables, Let's have a brief look at what exactly can be done with numbers, or some important information you should have on them. So we got integers and floats, that's no news to you. Here are examples for integers, and the important part here is an integer in Python can be as big or small if it's a negative number as supported by your memory and operating system. Because 64-bit systems, for example, can leverage more of the memory than 32-bit systems. That's why the operating system also matters. But the important part is, this is the only limiting factor. There is no built-in cap or limit. So if you want to store a really big number in a variable, you can probably do that if your memory supports it. Now, another important piece of information, sometimes you have some data in a different data type. Let's say you have a valid number which for some reason is stored in a string, so text. Let's say you have the text 10. You recognize that it's text because of these rounding quotation marks, but you'd like to do a calculation with it. Now let me show you how this would work. Here's an example. Let's say I have my age, which is 29, but notice the surrounding quotation marks. If I now output age plus 1 here, you see I get an error that this must be a string, not an integer, because age is a string, but 1 is an integer. So what would work is age plus 1, and now we would have 291, because it's now not doing the arithmetic addition, where it adds 1 to 29, it's just concatenating the two strings and creating one word out of the two. Now, this is of course fine if you had something like hello plus world, and you wanted to create one combined string. But it's not what you want if you're working with numbers. And to fix this, or to have a solution for this case too, there is a helpful function, int. If you wrap a string or a float with that function, it actually converts it to an integer, which you can of course then use as a normal integer, because it is a normal integer. So back to the example here, we could say int age, and this would convert the age string, which is 29, to an integer plus 1. And now we don't get an error anymore, so this error from above is gone, but now we get 30 as a result. Now, as a side note, if you wrap something which can't be converted, you get an error. If you wrap a float, you get the, well, rounded integer, to be precise. As you can see with 1.8, it always rounds down, so it basically creates the floor of it. It cuts off the decimal place. And if you wrap true, for example, it gives you 1, and int false would be 0. That's also an interesting convention to keep in mind. True converted to an integer is 1, false is 0. And of course, we can also do these conversions with negative numbers, as you can see. There, it also just cuts the decimal place. So this is the int function. For floats, we also got some examples here. It's also important to know that your memory and operating system is the limiting factor when it comes to the size, or the biggest number or the smallest number you can store. And just as with int, you got the float function to convert other types to float. Here's another example. Let's say age is 29 as a string again. Now we can also output float age, and we get 29.0 because it's converted to a float, so to a number, and as a special number, a float. Therefore, float age plus 1 would give us 30.0. If we set float true, or if we write this, we get 1.0, and float false is, what would you guess? It's 0.0. So it's basically the same result as with the int function, but always attaching a decimal place. So just as the int function, this is very useful if you got some data in the wrong data type, but with a value which you know that it can be treated as a number, and then you got an easy way of converting that data type to a number. Now, one final piece of important information I want to share with you. Both integers and floats can also be written like this here at the bottom. You can add underscores to make long numbers easier to read. So let's say if I would store the amount of fans I got, which certainly is 1 million, then I can of course do it like this. This is a bit hard to read though, so what I can do is I can also write it like this. For output fans, I still get the other format because that's the number with which Python will calculate. But when assigning the value, this clearly is easier to read. If I output fans plus 1, I still get the more unreadable output though, because again, internally, there only is one type of number. This underscore syntax is only there for improved readability. We had a closer look at numbers. Now, before we have a closer look at booleans and strings, let's have a look at something where we already used one part, operators. Now, we already used the plus operator to add two numbers. I guess it's pretty clear what the plus operator does. It's called operator because we perform an operation with it. We add two numbers in this case. Now, of course, Python has more than the addition operator. We can also do subtractions, for example. We can simply take two numbers and subtract them from each other. Now, of course, we're not limited to that. We can do all the basic arithmetic, so we can also multiply numbers. We can also divide numbers, like this. And here the important part just is, here, note that we're dividing two integers, 5 and 10, but the result by default actually is a float. So Python does not give us an integer, something like 0 maybe, because it cuts off the decimal place, but it does the conversion to a float for us and gives us that float result. Now, if you want to have the other behavior though, if you want to get an integer as a result, you can use the double slashes. That is the floor division operator. Here, for the same operation with the double slash operator, we get 0 as a result because it automatically cuts off the decimal place. We also got two asterisks, which would be the power operator. So if we got 5 to the power of 10, for example, we would get that result here. So this is really just allowing us to do some exponential calculations. Now, last but not least, one other core operator we gotta know is the modulus operator. We can use it to get the remainder of a division. So in this case here, 5 divided by 10. We can't divide this. 10 doesn't fit into 5 one single time, so the remainder is 5, and that would be the result. Now, one important note about these operators, the plus operator also works with strings, as you already saw. You can concatenate two strings. And the multiplication operator also kind of works with strings, but only if used correctly. Let me show you what this means. If we got a string like hello and another string like world, if we add the plus, so the addition operator, Python will concatenate both into one string. So if we create a greeting variable and we store that hello world text I just created and we output greeting thereafter, then we just get hello world here, so one string. Now that's good to know. I also mentioned that you can multiply strings. Now what I don't mean is that you can do hello times world. If you try that, you'll get an error, because this is a type of multiplication Python is not capable of doing. What you can do, however, is you can take a character or also some text, like hello, and multiply it with a number, like 10. And then Python will repeat that text 10 times and concatenate it into one string. This is often useful if you create some kind of graphical output with, let's say, some separation. You want to create a horizontal line. Well, you can do it like that. This is what you can do with strings. The other operators, which you use just with numbers, and that includes both integers and floats, should be pretty clear, and simply play around with them to learn more about them. With these very basics about numbers and operators out of the way, you're probably wondering how we'll use that in the blockchain. Well, we'll use that data to store it as data in our blockchain, so as the amount of coins we're sending with a transaction, for example. But before we do that, there are two important things I want you to understand about numbers, because you might encounter it and then it might look strange. One is, you can also write longer numbers in an exponential notation, like 1e10. That is a valid number, which Python will read and store as this number. So this here would be 1 million, for example. And as you can see, it automatically stores it as a float. And the even more important part is if you do some subtraction like 1 minus 0.9, what would you expect as a result? Well, you clearly would expect 0.1, right? But if you hit enter, you actually get a value close to 0.1. Now, this clearly is not the value we expected. We expected 0.1 as a result. Now, the reason for this strange looking result is that, as you might know, computers work with zeros and ones. They work in the binary system. Therefore, any floating point number is a challenge for them. And that's not just the case for Python, but for any programming language. The reason for this being a challenge is that anything which is a decimal place, no matter if it's 100.1 or 0.1, is lower than 1. So the part after the dot always is lower than 1, per definition. Now, values lower than 1 are difficult because they only know 0 and 1. So values lower than 1 have to be reflected as a fraction of 1. And when doing these fractions, they run into problems if you're working with values which are hard to divide by 2. So if it's not a binary fraction and 0.9 isn't, then you'll have a problem. For that reason, 1 minus 0.5 actually leads to a clean result because 0.5 can be written by the computer or understood by the computer as 1 divided by 2. Now, 0.9 cannot be written like this because there is no integer by which we can divide 1 which will lead to 0.9. Hence, it will actually chain a couple of divisions, and that would really be too complex here, which leads to the computer getting closer to 0.9. But it never fully reaches it, and therefore 1 minus 0.9 actually leads to this strange output. And therefore, even if you type 1 minus 0.9 minus 0.1, you get a value very close to 0, but not exactly 0. So this is a limitation or a certain missing precision you have to be aware of. It's not really an issue in your day-to-day life, because these approximations actually give you a very close approximation, but it is something to be aware of. And most of all, I don't want you to wonder if somewhere in the course you see a value like this. It's coming from that missing floating point precision, which is inherent to computers and also therefore to Python. It's not an issue of Python though. It's something the computer basically, well, has its issues with. Now let's also have a brief look at how we work with strings. Strings are generally really easy to use. As you learned, you create a string and store it in a variable, for example, by using quotation marks. Either double single quotation marks with your text in between, or double quotation marks with the text in between. Either of the two can be used. You can't combine them though, so you can't open with a double quotation mark and close with a single one, or the other way around. So you have to stay consistent. The advantage of double quotation marks is that there you could also use the single quotation mark as part of the text, like in I'm pretty cool. Whereas for single quotation marks, this will fail. I'm pretty cool. There still is a way around this with single quotation marks too. You can escape that character, and I'll again dive into escaping later in this course, but you can add a backslash in front of the character you want to escape, and now it is accepted. And if you output the string, you see now you just got the single quotation mark and double quotation marks around it. But that are your options, double or single quotation marks. Now if you got a longer text, you also sometimes want to have multi-line text. And you can create multi-line strings by using 3 double quotation marks, opening and closing. And in between, you can add your text, which can also span multiple lines. As you can see here, if I don't close it, but just open it, you can add your text. Then you can continue typing on the next line, which can span multiple lines, and close it with 3 double quotation marks once you're done. And then your longer text is actually inlined, if you output it, with another special character in between for the line breaks. \n marks a line break. But this makes entering it much more convenient since you can really type it across multiple lines too. Now I'll come back to working with strings and escape characters like this later in the course. For now, it's important to know that you can have single or double quotation marks, or for a multi-line text, also triple double quotation marks. Enough about the basic data types. We want to build a blockchain. We've had a first look at the data we're going to store in that blockchain, so in the blocks of our blockchain. And later in the course, we'll of course refine that data to reflect a full transaction and not just one word or one number. But for the blockchain, we also need the chain part. And for that, we'll use a list. A list in Python is created with squared brackets. You might know it as an array in other programming languages. A list holds different values. They can be of the same type, so it can be a list of numbers or text, but it can also be a mixed list, like this one. This list has some text, a floating number, a boolean, and even a nested list, which in turn holds some text and a number. Important, the elements in a list are separated with commas, and a list in Python has a certain length which we can get from it. In this case, it would be 4. This gives us the information about how many values are inside of a list. Now, typically, we don't just want to have a list to look at it. We also want to be able to access the elements in our list and change them or output them. And for that, we'll need something which is called the index. Each element in the list has its own index, and here is something very important, which is something you have to memorize. The index in Python lists starts with 0. So we got 0, 1, 2, 3. We got 4 values, but the first value has an index of 0. Therefore, the last value in this case has an index of 3. And accessing values by their index is actually super simple. We take the variable name in which we store the list. Let's say it's my list. And then we use squared brackets and the index to output or to access the values stored at this index. So in this case, it would be some text. Let's have a look at this in practice. Let's say we're creating our blockchain, and therefore I'll create my blockchain variable. And this holds a list, as I said, we created with square brackets, where we now add values. Now, we obviously are building our coin in this course here. So let's say our values are the amounts of coins we're sending with transactions. Right now, we unfortunately have no way of storing the sender and receiver of the coins. We'll do that later in the course, of course, once we had a look at more complex data structures. But the amounts is something we can already store. So let's say in the first transaction, we sent 1 coin. In the second transaction, it's 8.6 coins. In the third transaction, it was 5.1 coin. Of course, no one's stopping us from also adding some text here. So this is really something you as a developer set up. So this is our blockchain. Obviously, with hard-coded values, no chance for the user to input his own value. If I hit enter and I then output blockchain like this, here is our list. Now let's say I want to have a look at that second transaction only. Then I can access it with blockchain and then here what? 1. Because remember, the index starts with 0, so the first element, 1 in this case, has an index of 0. If we want to access the second element, 8.6, it's index 1. And correctly, we get 8.6 as an output here. Now we can also use these values in operations. Let's say we're some kind of hacker and we're changing the amount of coins sent in the second transaction. So we could say blockchain plus 2. If we enter this, we get 10.6, but interesting enough, if I then output the blockchain list again, you see here the value is unchanged. Now, why is that? The reason for this is that with blockchain 1, we're basically copying the value out of the list. We're not setting up some live connection to the element. So if I add 2 here, I'm adding this to the copied element. And hence, if I do add this here, we correctly get 10.6 because we copy 8.6 out of the list and then we add 2. But the original list, as you can see, is unchanged. Now that copying part is actually something which will become important later again, once we also work with more complex data structures, because there I will show you how you actually have to differentiate between different data types, where some are copied automatically, whilst others are not. But for now, with strings, numbers, and booleans, it works exactly as I explained it here. Typically, you're not looking to hardcode your array and then leave it like this. You got certain circumstances where you want to do something to your list at certain points of time in your code. Let's say we want to add an element. Now our list is set up there, and of course we could add an element by simply redefining the entire list like this. And now we add 10 as a new element, and if I output blockchain, we correctly see the new list. This is very cumbersome though. Manually recreating the list all the time, not really something we want to do. Thankfully, there is a special function or method we can use. Now I'll dive deeper into what functions and methods are in just a second. But for now, let's simply call it by adding .append after our list. That's a built-in method shipping with Python, and add parentheses here. Now if you add free here, and you then output the blockchain again, you see that free was ended at the end. So whatever this method or function is, again, we'll have a look at this in just a second, it seems to take that value we pass to it between the parentheses, and in the case of the append method, add it to our list. Now we also have a different method which we can call, and there are more methods than just these two, by the way, pop. And this will actually return a value instantly, free, which was the last value on our list. And if I now output the list, you see the last value is missing. So pop is actually removing the last element of a list, outputs it, or gives us the chance to store it in a variable. If we would use blockchain pop on the right sign of an equal sign, where we store it in a variable. And then it manipulates the original list and removes the element from there. So that's a first glimpse at functions, something we'll dive also in the next lectures. And this is how we can in general work with the list and how we can start building our blockchain. And actually, whilst this blockchain is very simple, this is how we will work with it throughout the course. We'll manage our blockchain in a list, and later the things will change is, of course, how we work with it, how we manipulate it, how we verify it and check if it's valid, the type of data we store, it'll be more complex, and of course, we'll also learn how we store it in a file so that it's not lost if we restart the program. Because right now, if I quit here and I go back into my REPL mode, the blockchain is gone. This variable does not exist anymore because it basically resets the old state whenever we restart this. So that's also something we'll fix throughout the course once we can store that in files. So we got the very basics about Python out of the way. We'll learn about the core data types and how we store them in variables. However, thus far we did everything in the REPL. Now we'll switch to a real development environment and to a local IDE. And we'll continue building our blockchain. In the end, we want to have a chain, which will be a list, which holds our blocks of data. And here's something new. I want each block to be a list on its own, on itself. And in that list of data, basically, so inside of the block, we'll then store our values. And for the first block, it might be one value, but the important part is for the other blocks in the blockchain, each nested list will actually always contain the previous values to kind of simulate that part which I mentioned earlier in the course, where each block knows about its previous block by its hash. Now we won't hash it here because that requires some knowledge we don't have yet, but we'll kind of fake it by ensuring that every block is just a nested list which contains the previous values as well as the new value. So it's basically like that game where you're packing your bags for leaving and you name one word like toothbrush, and your partner then has to name your word, toothbrush, as well as a new word, towel. And then you say toothbrush, towel, and let's say a comp. And that is basically what we'll do here. Each block contains the old data plus a new one, and this is something we can totally build with the knowledge we already have. And of course, we don't want to use random data. We're going to build our own coin. So let's start by storing transaction values. And obviously, we'll refine the values throughout the course. Now, as I said, we won't do this in the REPL though. We'll use a local IDE and a more elaborate setup, which you typically use for any bigger project you build. To work locally, we'll work with text files, and we want to write code in these text files which is easy for us to write and to understand. And for this, we'll use an IDE, an integrated development environment, which is a tool, basically a text editor, with a lot of additional features, which make writing code more fun and easier, because we'll get suggestions, errors will be shown to us automatically, we get different colors for keywords, and so on. It's more fun to write code with an IDE. Theoretically, you can use a normal text editor like the one shipping with your operating system though. For this course, I'll use Visual Studio Code. It's a free IDE, and you can download it from code.visualstudio.com. Make sure to choose your version for your operating system and simply download and install it. There should be nothing complicated about that. Now, there also is an alternative which I want to bring to your attention. It's called PyCharm, and you can simply Google for it and click on that link you should find there. And whilst there is a paid version of PyCharm, there also is a free version of it. You simply have to scroll down a bit and then pick that PyCharm Community Edition. You can download that for free and use it for free. And this is a different IDE, also bringing the advantages like color coding and so on, which you can also try out. However, I'll go with Visual Studio Code. Once you installed Visual Studio Code, you can open a folder, which you should simply create in your Mac Finder or Windows Explorer, where you will store your project. So this blockchain project. Simply create a new folder somewhere on your machine for that, an empty folder. Then you pick Open Folder and simply navigate to that folder. Here I selected my Python blockchain folder and I'll click Open. And now this opens the folder in the IDE. Let me hide this here. And now if your installation looks a bit differently, I simply entered presentation mode here and removed the toolbar at the bottom, for example. And what I also did is I switched the theme to dark. You can do that from the menu by clicking on Preferences, Color Theme. There you have the choice of different built-in themes, and I simply choose dark plus this default dark theme. This is my setup here. Now to work with Python, we also want to install some extensions that make that a bit easier. For this, you can simply go to View and then Extensions, or if you didn't remove that sidebar, you'll also have an extension buttons here on the left, but View Extensions will always work. And in there, you can search for Python. Now, I already installed it, but this first Python package here is the one I recommend installing. As I said, I have it installed, but you'll have an install button here. Simply click it and restart the IDE when prompted to do so. Now, additionally, in this course, and this is totally optional, I'll use the material icon theme here, which simply changes the file icons which will be displayed in this project. You can also install that, but again, this is purely optional. The Python extension is one you should install though. Thereafter, you can go back to View Explorer. Now in here, you can create a new file by clicking this New File button, or a new folder with that button, or with Command N. And here I'll add my blockchain file. The important part is, since we're working with Python, it has to end with .py. This turns it into a Python file. Now let me quickly switch to my other icon theme. Yeah, I prefer that. So this is my blockchain Python file. And this is the file with which I'll work for the next lectures. Now, obviously, you might be wondering, how do we execute that file now? And the answer is from within your terminal. In Visual Studio Code, you can also go to View, Integrated Terminal, or use the shortcut which is displayed there. And this will open your normal operating system command prompt or terminal automatically navigated into your project folder. And there you can run Python and then a blank and then the name of the file, like blockchain.py in this case, and it'll execute that file. And in this case, it does nothing because there's nothing in the file. But if I were to, for example, use print, a function which outputs something to the console, if you're not using the REPL, you'll have to explicitly tell Python to output something. So if you use print and you output 2 plus 2, for example, and you save the file, don't forget that. If you run the command again, you see 4 down here. So this is how we work with files and how we work with Visual Studio Code as our IDE. And with that, let's continue. And I mentioned print is a function, right? And we saw that append and pop function too. So let's dive into functions next, because this will allow us to create a better blockchain. What are functions? If we use built-in functions, we get some utility out of the box. Some magic happens behind the scenes which we don't know, but which does good things for us typically. But of course, we can also define functions for ourselves. And functions simply allow us to define code which is executed later, and possibly multiple times. And we, of course, define when it's executed. A function in Python is defined like this. We use the def keyword, then the name of the function, then parentheses, and then a colon. If you're coming from a different programming language like JavaScript, you would have the function keyword and curly braces. Now, Python uses def instead of function and colon instead of curly braces. And now that's very important to understand. It then uses indentation, so some white space to the left. You should use 4 spaces here to provide or write the code that will be executed whenever you call the function. Now, calling the function is something which is done like that, or like that. This is the multiple times execution I'm referring to. When you define the function, so the first part in this box, nothing will happen. Python will recognize that, but not run the code in there. As soon as you call it, though, by using that function name with parentheses, it will execute the function and run the code that's in there. Now, regarding the syntax, also note that in Python, not only in functions, but actually entirely in Python, you don't use semicolons at the end of the line. And again, you don't use curly braces, you use indentation. And you should use 4 spaces instead of tabs here. However, the good thing is, in IDEs like Visual Studio Code, you can actually hit the tab button and it will enter 4 spaces for you. So you got that convenience. Back to the functions though. This is a simple function here. It simply outputs something. Now let's actually use that in conjunction with our blockchain. Let's start building our blockchain with the help of functions. In our blockchain.py code here, I will first of all recreate my blockchain variable. And also as a side note, unlike in other languages, you don't have a var or something like that in front of that. You just type the name of the variable. And this should be a list. And actually, it's an empty list at the beginning. Now, we obviously want to add values to that list. And for that, we can use a function. So we define a function here. And I'll name it add_value. This again is that naming convention, which also applies to functions, where you write it entirely lowercase and you separate words with an underscore. Now important, when defining a function, you have to add a pair of parentheses and then a colon. And the nice thing is, you can already see the color coding here in Visual Studio Code. So that's support for the keyword, which is marked blue, and your own name, which is yellow. If you hit enter now, you see it automatically indents this line, so it helps you with that. That's part of the reason why we use an IDE. Now here we write the logic we want to execute when we call this function. And this can be more than one line, by the way. Now here I want to add a value to the blockchain. Here we see another IDE feature. We get suggestions on which methods we can call on a list. So it detects that blockchain holds a list and helps us with working with it. Now I want to call append here. And now we also get some information about what we can do with append. And I want to append a value. Now let's say we append 5.3. I will now also add a second line, still in that function. I would be outside of the function if I remove the indentation, but if I keep it, I'm inside of the function body. And here I will use a built-in function, shipping with Python, which is print. Print is a function which allows us to output something to the console. And here I simply want to output the latest version of my blockchain. Now we can go down and I simply enter an empty line to make the code more readable. And I remove the indentation by using Shift and Tab. And I can now simply call add value by using the function name as well as the parentheses, like this. If I save that file and I go into my terminal, I can now execute my blockchain.py file with the Python command. And as you see, it outputs my list here. Now, if I execute it again, I still only got that list. So it's not storing that list between executions because basically our program runs and then it's done and it loses its state thereafter. If you wanted to persist it, you'd have to store it in a file, something we'll also do later. But of course, we can go back and we can replicate or call add value multiple times. And if we do so and we execute this again, you see our chain grows. Now, right now, we're just storing float values there, though. If you remember that slide from earlier, I said that I want to store nested lists in there, which have the old transactions as well as the new one. For this, back in our function, I'll actually append a new list here, and that list holds the new value, but I also want to hold the last value, so the last value of my blockchain here. To do this, I'll reference blockchain as a first value. However, blockchain should not be entered entirely, just the last value we have in there. So we need to access a certain index. Now, index 0 would always be the first value. If we do that and we save that file and I execute Python blockchain, we actually get an error because we try to access a value which doesn't exist at the beginning, right? We try to enter blockchain 0 when it is empty at the beginning. If we start with a value of 1, let's say, and I re-execute this, now it works and you see we're growing and we always have that value in there. But of course, we always refer to the first value. Now, there is a convenient trick about indexing which helps us get that last value. So we start working with functions and we start storing data in our blockchain by appending a new value and also referring to the old value. Now, right now we're always referring to the first value though, which always is a 1 because that is what we start with. If we want to get the last value of the blockchain list, we actually can use -1 though. That's a convenient trick, though trick sounds like it's some workaround. It's actually a built-in functionality which simply accesses the blockchain from the right. So 0 is the first element from the left, but -1 is the last element because we start accessing it from the right. And why not -0? Because there exists no such thing as a -0. So -1, we could also use -2 to use the second last element, but -1 will actually now give us the last one. If we save that and I run that code again, you see now what we have is we got our blockchain here in the last line where we have 1 and the new array with 1 and 5 free. And then we're nesting this further and further, as you can see, because we're always referring to the last element of our blockchain, and the last element will always be a nested list. Now, actually, for that reason, we should also wrap that starting 1 with another pair of squared brackets so that this is a nested list too. Now, with that, if I clear this to make it easier to read, here we see how we now execute our code. We always add an additional level of nesting, because if we access the last element in the second add value call, we get this result because here the last element actually is this list. So when we append a new value to our blockchain, we take the old blockchain, which is this part, and then we append the old last value, so this one, we append it as the first element in that new array we're adding. Remember, we're adding an array here with square brackets. This is what we append. And then this new array or this new list actually also has this value here at the end. And for the last add value call, this is the part we're starting with. And then we're appending a new list, hence the outer squared brackets here. And in that new list, we have 5.3 as a new value, this value. But then we access the last value of the old blockchain, which is this value here. And this is why you now see this value with 3 opening and 1 closing square bracket in here. So this is the same value as this up here. And that simply is added because it's the last value of the old blockchain. So this is the logic we have right now. Each new block we add contains the old data as well as the new data. The problem we, of course, is the new data always is the same. It never differs. It's always 5.3. So it would be nice if we could actually manipulate that and tell the function here to use different values. We learned how functions can work in general. One nice feature of functions is they can do much more than what we previously did. They can receive arguments. This means that in our function, we can expect arguments, parameters, between the opening and closing parentheses next to the function name. And we can use these arguments inside of the function, like that. If we then call the function, we have to pass a value for that parameter, and this is then dynamically injected into the function. So this would actually print hello max here. Now let's apply this to our blockchain. In add value, we can add an argument, and you can name that argument whatever you want, like val or value or transaction amount, something like this. And you can use that value inside of your function body, not outside of it. It's only known inside of it. So we can use that like a variable name here and add it here instead of 5.3. And we could, of course, also use that in calculations or in any operations we perform on it. So this is my transaction amount here. And now, if I save that, and I clear that just to make it easier to read, if I execute the file, we get an error. We get an error that add value is missing one required positional argument, transaction amount. And we also see in the IDE, we got these red squiggly lines. The reason for this is, obviously, add value requires this data to work correctly. So we have to pass it. Can pass 2.9, 10.89, for example. And now if we save that file again, and we execute it again, now this works, and now you see that our values are indeed inserted. 2, 0.9, 10.89. This is now taking advantage of the fact that you can pass arguments to functions. And if you have a look at this append function, the strange thing still is that we call it on a list. Well, that has something to do with objects and methods. We'll have a look at this later in the course. But in its core, it's a function. And there you can see we also pass an argument, right? We pass the argument we want to append. So append actually also is a function that takes some input. We already learned some nice things about functions, but they can do even more than what we learned this far. They can also return values. And what does this mean? Here's an example. We got our sum function here, and as you can see, this function takes 2 arguments. But any function, no matter if it takes any arguments or how many it takes, can also return a value with the return keyword. If you use that inside of a function, whatever comes after it is returned, which means that whoever called that function will get that return value as a result. In this case here, we call sum inside of the print function, which will output the value returned by sum. We could, of course, alternatively also simply store the result of sum in a variable by using the variable name and then an equal sign and then the sum function call. Now let's also apply this to our blockchain. Right now we got one function which does two things actually. It gives us the last value in our blockchain, and then it appends this value as well as our new transaction amount to the blockchain. Let's actually split it in two functions. So I'll define a new function with the def keyword, and I'll name it get last blockchain value. Now that's obviously a pretty long name. You can shorten it, but one idea behind Python really is that you write code that is readable. Readable code is really a core value of the Python community. So using function names like this is actually perfectly fine. This function will not take any arguments, still requires a colon, of course. And what we'll do in here is we'll return blockchain -1. So this will do the extraction for us. What this simply means is that in this function here, we can call get last blockchain value. Now, arguably, that got longer, but from a code reusability perspective here, we got cleaner because now each function has only one job: extract and append. Well, actually, this function still also prints it. But besides that, it only has this one job, and we can remove that print statement, of course, and simply print the blockchain at the end once we're done. So with this, we got two functions now, and now it's also a convention that we should have two empty lines between our function definitions. This is something from the official Python code style guide. I will tell you more about that guide at the end of this module. In Visual Studio Code, you also got a nice tool. If you go to Code, Preferences, Keyboard Shortcuts, and there you search for Format, you'll find that Format document shortcut. Bind it to anything you want. And with that shortcut, you can automatically format your code in a way that it follows the official style guide. So that's very convenient. So now we got two functions here. If I now clear the console and execute my script again, you see we get an error here. But the reason for this simply is that I accidentally deleted the opening square bracket. I need to keep this because that last value I'm extracting should still go into a new list. So if I save this and we now execute this again, now we only get one output because I only got one print statement now. But here you see it's still extracting the old list and inserting this here, and then also this one into here. So this is still working, but now split up over two functions with the help of the return keyword. Returning values is pretty neat. Now let's go back to arguments though. You learned how you can use function arguments. One additional nice feature is the fact that you can also use default arguments. This means you can set up a default argument which will be used if you call that function without passing the data for that argument. Remember, previously we got an error in this case. With default arguments, this is actually something we can do without errors. Here's how it works. We get a function definition with the greet function in this case again, and now the age part here actually is a default argument. We provide a default value for it, 29. Then we use it in our function, and the interesting part, of course, is when we call the function, you see I actually don't pass a second argument. Without a default argument, we would have to do that, otherwise we'll get an error. But in this case, it works fine without it. Let's also use that in our blockchain example. We have a good use case for that with our starting value here. Let's go back to initializing the blockchain as an empty array. Now, clearly, if I now clear that and execute my code, we get an error because with getLastBlockchainValue, we try to extract the value which doesn't exist. Now, let's fix this by using a default argument. Here in addValue, I'll use add my last transaction value. And this is now actually what I will append as a first value in the new block. Last transaction. Now what I can do is, I can of course pass that as an argument to my add value call. Now I do that by, for example, passing get last blockchain value, and don't forget the opening and closing parentheses. Now if I do that, what do I provide for the first add value? Well, I can provide my starting array here. So what we previously added directly to our blockchain definition up here. With this code, if I run it, it'll work fine and it'll give me the exact same result as before. But we're not using default arguments here. And actually, we can improve our code by doing so. The default obviously is that we want to get the last blockchain value. So it would be nice if we could still use add value like this. But obviously, this gives us an error, as my IDE shows. So what we can do is we can go into our add value definition and add our default argument by adding an equal sign after the argument name and then the default value. In this case, this function call to get last blockchain value. If I now save this and I execute the file again, this unfortunately doesn't work. The reason for this is it still executes that even if we do provide a value. And therefore, it still executes that for the first add value call where we have no last value. So we'll have to fall back to the second best solution. We'll provide our 1 here, so this 1 array, as a default value so that we can omit it here for the first add value call. And unfortunately, we'll have to use the longer version for the subsequent add value calls. But still, we now got a different way of making sure that we don't run into this below error. And we're taking advantage of default arguments. Something we'll of course also see a lot throughout the course. So now with that, if I clear this and now I execute that file, it works again. The second best solution as I mentioned, but also just one of the many examples you'll see throughout the course. Now we're almost done with functions, but here's one last nice feature you should be aware of, and that are keyword arguments. Now what's that again? It's actually not that difficult. We got a function with 2 arguments, name and age. Here's what happens in the function we just outputted. And now with keyword arguments, we can actually also call a function like this. In our function call, we use the name of the argument, name and age, and an equal sign, and then the value we want to pass. Normally, if you don't refer to the names in the function call, the position defines which argument receives which value. The first data you pass goes into the first argument, the second data goes into the second argument, of course. With keyword arguments, you can switch the position or also omit some argument after which another argument comes which you don't want to omit, for example. Now let's also add this to our course. And let's take advantage of positional arguments by simply reversing the order for this second add value call. So I want to use get last blockchain value as a first argument. Now, of course, I can switch it like this. I'm not using my names here. And if I execute this, on the first sight, it looks like it worked, but of course, it didn't work. We're actually now adding our values incorrectly for that second add value call, which is the reason why here we have 0.9 as a first value and the old blockchain as a second value instead of the other way around, which we normally want. If for some reason we wanted to call it like this, however, we can do this with the named arguments or with keyword arguments, how it's officially called. We can say, or we can pass that information to the function which data should go into which argument. So I could say, hey, this should actually be the last transaction by using last transaction equal and then the value that should be put into it. And this, on the other hand here, is the transaction amount, also with an equal sign. And now with this, if we repeat that, it still works, but you can already see there's a difference. This now is the correct blockchain again and not the wrong one. So here, We're now taking advantage of keyword arguments, and this is everything you need to know about functions right now. How you define them in general, that you can pass arguments, that you can return data, that you can provide default arguments, and that you can use keyword arguments, which simply means you use the argument name when calling the function, and you got greater control over which argument receives which data, therefore. So we're working on our blockchain. It's slowly taking shape, but wouldn't it be nice if the user could actually enter the values we want to append? So let's add a functionality for that. We can get the user input with the help of a special built-in function, the input function. This now allows us to provide a string. Remember, that's a different data type, some text, which is presented to the user. And then the user enters something and hits enter, and whatever the user entered is put back into our code, so to say. So we could say, your transaction amount, please, like that. And we could store that in tx amount, tx for transaction. Now we could then use tx amount here as the value we store. Please note that I don't replace it for the other function calls for now. If I now save this and I execute this file, you actually see down there the execution stops. It's not printing the final blockchain. Instead, it's executing this code where we're prompted for the transaction amount. Now I can enter 5.99. If I hit enter, the execution continues, but you now see that this was entered as text though, because, and that's something you have to memorize, whatever you pass into your code with input is treated as text. But we learned how we can convert it to a number. Do you remember? We can wrap it with int to convert it to integer, but obviously we want to support floating point numbers, so we can wrap it with float. And now we're able to handle user input, which is text, as a float. So if we repeat this, and I now enter 5.99 again, now you see there are no quotation marks anymore. Now it's really stored as a number. Now obviously, we don't just want to execute this once. We want to execute this before every transaction here. So before every add value call. For this, we fetch a new input before every call with the input method, and we store it in the same variable all the time. And of course, we should then use that variable in our add value function. So now if we save that and clear, and I execute that file again, I'm asked for a value like 100, then 99.9, and 4.8. And once I'm done, you see the 100, also present in the old value, of course, the 99.9, and 4.8, they're all stored in our blockchain. Now, we're doing one thing here, which we should avoid though. The one thing we're doing, which we should try to avoid, is we are actually always repeating ourselves. We're calling that same code, we're executing the same code 3 times here. Now, we should try to minimize the code where we repeat ourselves. And to be honest, this will become easier after the next module, where we learn how to loop through code and therefore repeat it automatically. But one thing we can already do is we can define a new function with the def keyword, which is get user input. I don't expect arguments here. And in the function body, I'll simply execute my input statement and already convert it to a float, like this. Now, obviously, the value we get here is not useful inside of our function. So what can we do? We can return the value. And by doing so, we can simply store it in tx amount thereafter. Get user input like this. We're still repeating ourselves, to be honest, but again, this is something we can fix after the next module, but at least it's shorter code now. And we outsourced the core functionality, the input and the float method here, into a separate function, which we now call, and where we store the result, which is returned with return, in a new variable, which we then pass to add value. And with that, we can execute that file, and we're again prompted for some input here. And as you can see, this still works as before, but we got leaner code. We're repeating ourselves less, and that really is something you should take with you. Try to minimize or totally avoid repeating yourselves. And we're again using a function, this time again with the return statement. We're almost done with the module. We learned a lot about functions and now also how to handle user input. There's one important concept which we already used, but which I want you to understand though, and that is the scope of variables. What do I mean with that? We got global and local scope. Now what's global scope? If we define a variable directly in our file, so on the root level, so to say, not inside a function, like here, then we can use that variable anywhere in that file. We can use it in the greet function, and we could also use it outside of there. A local variable, on the other hand, is a variable only available inside of a function. This would include function arguments or variables which are defined inside a function, like the age variable here. Using this variable outside of that function would actually fail. Let me show this to you. Back in our code, we got that blockchain variable here. We define it at the very beginning of our code, and most importantly, we define it outside of a function. Doesn't matter that we define it here at the top of the file. Well, our other code wouldn't work, but theoretically, it would also be a global function if we define it down there. However, the important part is, as you can see, we can absolutely use that variable inside of function because it's global. We can use it outside of it, as we do here when we are printing it, and we can use it inside of a function, like we're doing here. Now, on the other hand, local variables are seen here, for example, transaction amount and last transaction. Now, these are obviously arguments of our function, but in the function, we use them just as variables. If we try to output our variable outside of a function, though, that won't work. So if we try to output transaction amount here after our first add value call, so it certainly is populated with a value. If we do that, if I execute the file and I enter 10, you see thereafter I get an error that the name transaction amount is not defined. And the reason for this is that this indeed is not defined because it's not a global variable. It's not defined in the file itself. It's only available in that function. The same would be true for the user input, by the way. If we create a user input variable in which we store the user input, and then we simply return that here, this will continue to work. We're just using an in-between step, maybe to make it easier to read. But if we now output user input here, well, you're probably already guessing it. But if I repeat that execution and I enter some value, I also get an error on that. Name user input is not defined because it's a local variable only available inside of a function. This is a key concept you also have to be aware of. Variables defined in a function, be that by doing it like this or as an argument, are only available in that function. On the other hand, global variables are available everywhere in your entire file here. Now, there's one important thing you have to know about global and local scope, and I'll show this in the REPL. First of all, we can define a function there too with the def keyword, like print name, colon, and if you hit enter, you see 3 dots at the beginning. You can now hit tab to indent and write your function body here. And here, we can of course use a local variable, like name, max, and thereafter indent again, print name. And we can obviously, as you know, you get out of the body here by hitting enter twice. You can now call print name like that and you see max. Now that's not that new. Now let's say we have a name here, again, max, and this now is a global variable because it's not defined inside of a function. Then we define a function, maybe getName, and here we're prompting the user for input. And we want to store that input in the name variable. So name, input your name, like that. So this will store whatever we enter in the name variable. And thereafter, outside of the function, I first of all execute getName to get that input. And after executing that, I'll print name. So first of all, let's hit that. And let's enter Michael. So a different name than is stored up here. So Michael in my case. And then I'll call print name. And if I hit enter, we see Max. The reason for that is that if you use a variable in a function and you assign a value to it, and that always happens if you use a single equal sign like this, so variable on the left and then equal sign and then whatever you want to store on the right. If you do that inside of a function, it will always by default create a new local variable. It will not store it in the global variable, even if such a variable with the same name exists. If you want to force Python to do that, so if you want to force it to actually store this in the global variable instead of creating a local one, there is a special keyword you can use and you have to use. So if we quit this, clear, on Windows this would be CLS by the way, and then we run Python again to go into the REPL. Let's again try this. Name max, global variable, and then let's define our function, getName, like this, indent, and now the special keyword is global, and then the name of the variable, name. And just like that, you don't immediately assign a value, but you just tell Python, hey, there is this global variable, please, if I use name in this function, use the global version of that. Of course, if no such global variable exists, you'll get a problem. So let's now hit enter and indent again. And now we can again use name, input your name like that. And now this will actually use the global name variable because we're telling it to do so here. So now if I hit enter again and I quit this function, if I now call getName here and I enter Michael now, and I now print name, you see now it's Michael and not Max anymore, because thanks to global name, this actually targets the global name variable instead of a new local one. Whew, we covered a lot of ground in this module. We learned a lot about the core basics. Now we'll continue diving into the basics. A great place for you to also dive deeper are the official docs, which you can find on python.org. Make sure to pick the .free, the free.x docs. And there the tutorial is a great place to learn all these basics again. Numbers, strings, lists, these are things we learn about. Now, if and so on, these are things we'll learn about in the next module. So you may jump ahead if you want, but there actually is no reason to do so. Something important or interesting I also want to show you from the official docs are the PEPs though. Now what's that? If you go back to python.org and hover back over documentation, and you go to PEP index, you'll find a list of all the Python enhancement proposals. These are basically documents, articles, giving you hints about how you can write your Python code, how you should write it, new developments in future Python versions, things like that. Now, if you scroll down, you'll find the index of all the PEPs, and you'll find a title about, well, what is covered in that PEP. Now, a very important PEP is this one here. PEP number 8 contains the style guide for Python code. If you click on it, you find useful information on how you should style your Python code. Now, you don't need to learn that by heart, but scanning through it is definitely recommended. You'll learn things like that there should be 2 empty lines between function definitions, that you should use spaces instead of tabs, which Visual Studio does by default, and how you should name your functions and variables, that lowercase thing with the underscores between the names. I'm already teaching you a good style in this course, but there also might be some features we just don't use in that course, or which you're not sure if you remember them correctly. So therefore, PEP 8 is a great place to dive in and learn more about the styling. The other PEPs can be interesting, but I recommend not going too deep into them. They can be really confusing, and they're not official documentation. They are recommendations, they are proposals. If you want to learn the core of the language, watch this course, of course, and fall back to the official docs for deep dives. Now, one thing you'll also find mentioned in the PEPs is how you comment your code. And that is something we didn't have a look at yet. You can create comments in Python by using the hash symbol. Like here, we could say initializing our blockchain list. Comments should be used to improve the readability of your code. But one core principle of Python also is that your code should be readable on its own. So you should have clear function and variable names, and your code actually shouldn't need too many comments. I'll still add quite a lot of comments, also outside of these videos, for the code which you can download, so that it's easier to understand for you. But in general, not many comments should be required. This, however, is one way of commenting. A common technique also is to sometimes comment out a certain value, like this, if you just want to test something without that being defined. Now here this doesn't make sense, but you'll see this occasionally throughout the course. There also is another way of commenting it, and that are so-called doc strings. These are essentially the multi-line strings you learned about, with the 3 quotation marks. You use them, for example, at the beginning of own functions, like this, 3 opening and 3 closing quotation marks. And in between, you comment your function, like returns the last value of the current blockchain. The cool thing here is most IDEs actually pick this up. Now, by default, this would be a normal Python string. It's not an official comment, but it also doesn't do any damage to your code. It kind of emerged, or it simply is the case now, that we use this syntax to comment our own files or our own functions. So we can use this and add this to a function. And now when we call getLastBlockchainValue, or if we use this in the IDE, we actually get support. As you can see, if I hover over this, here you see the text which I entered above. So that's very handy, especially if you're writing code that is shared with other developers. And it is a good practice to comment your own functions. Like here, append a new value as well as the last blockchain value to the blockchain. And doc strings are typically also written in a way that you have a first summary sentence, and if it's on a function like here, you then also should add something like arguments, and the exact style is up to you. I'll use this style arguments, then I'll use a colon, but this again is really up to you, and the name of an argument like transaction amount, and then a short information about that argument. The amount that should be added, and we got a second argument, last transaction, the last blockchain transaction. We can also add default 1. Now the advantage of this clearly is that whenever we use add value, we get that information. And if we're not the creator of that function, this of course is very helpful when it comes to us understanding that syntax. And this is also why we get highlighting, for example, for input. Here we also get some help in the IDE, well, because input is implemented like this, and because it also has a doc string. Now let's therefore complete our commenting exercise here by also adding something to get user input, returns the input of the user, a new transaction amount, as a float. Try to be as precise as possible so that if our developers were to use your code, they can understand what's happening. So these are comments added for general readability and to help our developers, as well as doc strings also added to help our developers, but also as a general good practice to make your code easier to understand and read. Now, when working with Python, you sometimes end up with code that's relatively long. Now, for example, this add value line here is a bit longer, or this doc string here. Now, for the doc string, you can easily add a new line by simply hitting enter, because you can write multi-line text with triple quotation marks, so that's no problem. With other code, so with non-comment code, You also can break lines. If you're in a list, like here, the arguments you're passing, you can add a new line by hitting enter after the comma. And this will still be valid code. Now I press the auto format button in my IDE. You can find it in the key bindings under preferences, keyboard shortcuts. And there, if you search for format, it's this format document shortcut. And then you see it ordered this a bit differently. It made sure that the arguments are beneath each other. It would work otherwise too. So if you have it indented like this, it would still work, but that's easier to read. Hence, that's the formatting it applies. But this is something you can do if you want to structure your code in such a way, if you want to avoid long lines, which you should. In this course, though, I will typically try to put expressions and code into one line, because whilst this can lead to you being required to scroll to the right a bit, I believe it helps understanding what belongs together, which expressions work together. So that is why I tend to use one or two lines only instead of splitting everything across multiple lines, but you can do that. So that's just a side note so that you don't wonder why I use relatively long lines where scrolling can be required. You have the opportunity of splitting that across multiple lines if you want to. So that's actually it for the module. We learned a lot about Python. We learned that we structure our code with indentation and colons for block statements like functions. We'll also learn about different block statements in the next module. We learned that we create functions with the special def keyword. And we learned that in general, we should follow PEP 8 when it comes to styling our code. From a feature perspective in this module, we learned about the core data types. Numbers, which comprises integers and floats, strings, as well as booleans. We also had a look at operators. We can do some base arithmetic with plus, minus, times, and by dividing values. But we also have the modulus operator, which allows us to get the remainder of a division. We got the floor division, which always returns an integer instead of a float. We got the power operator to calculate the power of a number to some other number. And it's important, we also learned that strings can be added and multiplied. Multiplication only works with one string and one integer, though. It also doesn't work with floats, by the way. We had a look at lists, and we learned how we can create lists with the squared brackets, that we can add items with the append function, that we can access items with their index, which starts at 0, and that we can use -1 to get the last value, and that there are other list operations like pop and so on. We saw them blink up when we used the list in the IDE, for example. Now, also important, we had a look at functions. We learned that indentation and colons define the function block, that we can use arguments, that we can return values, that we can also use default arguments, which allows us to omit arguments when calling the function, and that we can also assign values, data, to arguments by their names, so-called keyword arguments, where we can reorder arguments or skip them, provided that they have a default value. Now, last but not least, we also had a look at scope. There is global scope for variables defined outside of functions, and local scope for variables defined inside of functions. And this is actually it. Now, what about our blockchain status? We got a chain of data, we got a list of data. Of course, only a basic implementation. It's no complex data yet, but we'll refine this throughout the course. We're able to mine new blocks, and that, of course, is also something which will improve throughout the course. But now mining is a big word for asking for user input. And additionally, also in a basic way, we're able to hash our blocks. We always got this previous data in the next block. Now, we're not really taking advantage of this. We're not really able to analyze our data based on that, but it's a nice first step. And this, of course, is also something we'll improve. Now, there also are some things we haven't even had a look at, but hey, it's still only the first real module of this course. So let's continue to the next module and learn more about the blockchain and, of course, most importantly, about Python.